Welcome to the Doherty Water for Food podcast. Since 2010, the Doherty Water for Food Global Institute at the University of Nebraska has worked toward one goal, a food and water secure world. One in which global food security is ensured without compromising the use of water to meet other essential human and environmental needs. It's a daunting vision, but one that is vitally important. This podcast amplifies the voices of those making waves in this space. We hope you enjoy today's episode.
Hello and welcome to the Doherty Water for Food podcast. I'm Frances Hayes, Director of Communications and Public Relations for the Doherty Water for Food Global Institute and your host for this episode. Today I'm sitting down with Jackson Stansell, CEO and founder of Sentinel Fertigation, a Lincoln, Nebraska ag startup founded in 2021 that uses drone and satellite collected imagery to predict when a corn crop needs fertilization. The company just launched a web application called In Time that delivers real-time, imagery-based fertigation recommendations directly to users throughout the growing season, which translates to better nitrogen fertilizer use efficiency, saving growers money, and reducing environmental impact. Jackson has a connection to the Doherty Water for Food Global Institute. He received student support from the Institute while working on his master's in agricultural engineering at the University of Nebraska-Lincoln. And Jackson is now pursuing his PhD in biological engineering. Jackson, I'm excited to meet with you one-on-one today to discuss your company, your thoughts on the future of agriculture, and the path that led you here. So let's dive in. To start us off, tell us a little bit about yourself, your company, and how you came up with this idea initially. What was the need that you saw, and when did the idea develop?
First, thanks very much for having me, Frances. I'm glad to be here. Really have appreciated the Doherty Water for Food Institute support as a graduate student. To kind of talk about my story a little bit more, I'm from Southeast Alabama. Originally, did not grow up in a farming family, really from a farm background at all, but was exposed to agriculture in that part of the world. Dothan is the self-proclaimed peanut capital of the world. Grows about 50% of the nation's peanut crop within 100 miles of the town. And so one of my parents' biggest clients in their business was a peanut shelling and processing facility. So became aware of agriculture in high school, I would say, significantly. Went to Harvard for undergrad, played football there, got an engineering sciences degree. During that process, slowly started to gravitate towards the ag sector. Was originally really interested in biofuels. Spent a summer at Iowa State doing biofuels research, and really did not enjoy being cooped up in a lab all day, and got exposed to production agriculture there in Iowa. And subsequently decided to explore precision ag through some of my sensors and controls classes at Harvard. Came out to Nebraska to explore it a little bit more in person through an internship that was a research experience for undergraduates. Flew drones and carried sensors through a cornfield all summer for a nitrogen management study. And through that process really became quite aware of kind of the nitrogen dilemma that was facing agriculture and really facing Nebraska quite acutely. And really became hooked with precision ag in general, and decided to go back to Harvard, change my major to cross-disciplinary engineering sciences from more of a biochemical and materials track, and really combined both biological and environmental engineering in a program that replicated agricultural engineering. After that program was over, decided I needed to specialize in agricultural engineering, so I came out to UNL and became a graduate student for Dr. Joe Luck, and at that point became a Doherty Water for Food supported student, and started pursuing work on a project looking at using imagery to inform the timing of fertigation events. So essentially doing fertigation scheduling based on imagery. And so I ran that on-farm research project for 2.5 summers, basically throughout my master's program, and kind of recognized a real need for these image-based fertigation recommendations, especially relating to the nitrogen problems that are facing groundwater resources here in Nebraska. Nitrogen leaching is a really significant problem, especially in some of the sandier soils that are in the state. And it's something that impacts agricultural producers in Nebraska, as well as just people who are living in rural communities throughout the state. Just really seemed like a very impactful project and decided to pursue that. And that research has ultimately led to the formation of Sentinel Fertigation.
Can you fill us in a little bit more on what Sentinel does as far as how it works and how you get it in the hands of farmers?
When we were doing this at a research scale, our team would actually go out and collect UAV imagery. And what our system would do is we would take a UAV image. We would process that image to filter out any sort of features that didn't need to be considered in making nitrogen decisions for a crop. So those would include pivots, any other sort of structures in the fields, roads, soil pixels, anything that was not vegetative that we didn't want to look at, we got rid of in the images. Subsequently, we would move these images through an analytics process that took into account calibration plots out in the field to isolate nitrogen stress from other potential stress factors such as water stress, disease, anything like that. Essentially quantify the nitrogen status of the crop, and using that nitrogen status quantification, we were actually able to make a decision about whether or not a field required fertigation. And this was done at kind of a subfield basis, but with the idea that it could eventually translate to making decisions on a full field basis and really adapt to the level of application resolution that farmers have on the farm today, not necessarily having the latest and greatest technology, but enough technology to do a good job with timing of fertilizer applications and really make a positive impact on nitrogen use efficiency. And so that methodology is what we call the sensor-based fertigation framework. And that's exactly what Sentinel Fertigation is taking and extending out into the commercial marketplace, except now we're moving more into satellite imagery so that we have more frequent monitoring. During the research phases of this project, we were collecting imagery approximately weekly with UAVs and making those decisions on a weekly basis. And now with satellite imagery, we have the opportunity to essentially repeat that process on a daily basis. There are some of our fields right now that have gotten 3 to 4 images per day for the past 3 days with a satellite. And so we're able to make that analysis, make those decisions and recommendations essentially in real time on a day-to-day basis, and sometimes even an intraday basis, as I've mentioned, and stay on top of crop nitrogen stress. And so ultimately what we're trying to do is just help producers schedule fertigation more effectively and only apply nitrogen when the crop actually needs nitrogen.
I can see that when you apply nitrogen more precisely, usually results probably in using less fertilizer like nitrogen, and thus a cost savings to the grower. So that part's pretty easy to understand, but help us understand more about the sustainability part of your technology and how it applies to Nebraska groundwater.
So nitrogen is a really, really difficult nutrient to manage. Probably the most difficult nutrient to manage because it essentially moves the same way that water moves. And so if you think about water moving through sand in some cases, and you know how quickly that can happen, that's essentially how fast nitrogen is moving through the soil profile. Additionally, there are a lot of sources of nitrogen within our agricultural systems, whether you think about manure that's been applied to a field, whether you think about organic matter in the soils, so anything that's breaking down from cover crops, previous crop residue, those are sources of nitrogen. You can get nitrogen through irrigation water naturally, just as far as what is actually contained in the groundwater that's being pumped for irrigation. And so there are so many different sources by which nitrogen can become available to plants, and it moves really quickly through the soil profile. And all of these characteristics, combined with the fact that crops don't take up nitrogen consistently throughout the growing season and have variable needs over time, really make it a very complex system to manage. And in soils that don't retain nitrogen very well, which none retain nitrogen perfectly because nitrogen just naturally leaches. It's negatively charged, and most soils are also negatively charged, and so they don't have an attraction to each other. It really makes nitrogen very easy to lose through the soil profile and ultimately make its way all the way to our groundwater resources. If over-irrigation occurs or if we have precipitation and there's nitrogen on the soil surface, that also can lead to runoff. And so the whole idea is that really the soil is a terrible place to store nitrogen. And we want to try to keep nitrogen out of the soil as much as we can, except for that amount that is specifically needed by the crop. really in Nebraska, when we've had producers who have been historically over applying nitrogen, and producers have done a great job over the past 30 to 40 years of cutting back and starting to head in the right direction. But that historical over application of nitrogen has really put us in a bad place, from a groundwater quality perspective, and having quantities of nitrates in the groundwater that are well above the EPA maximum contaminant level. Really, with our technology and timing fertilizer applications to crop need and trying to minimize the amount of fertilizer that is applied to achieve certain yields, we're trying to really minimize the amount of nitrate that's making its way to the groundwater, ultimately improving groundwater quality, and hopefully enabling some value for farmers as well down the road through water quality markets and some other potential premium marketplaces that will be available around these sustainable practices on the farm.
Nitrogen-based fertilizers are most often applied to fields, but phosphorus and potassium are also common. Sentinel focuses on applying nitrogen fertilizer optimally through irrigation called fertigation. Can your technology also be applied with these other nutrients?
It's a really good question. Right now, it can't be. We're really all about isolating nitrogen and trying to control nitrogen applications. Phosphorus is interesting from the standpoint that it's obviously needed by the crop, but it's actually much easier for the soil to store phosphorus. And potassium is kind of the same way. Those nutrients can be built a whole lot better. What is interesting from kind of a yield boost perspective is some folks are looking at and are starting to apply potassium specifically via fertigation, although I've heard some phosphorus as well, because there have been shown to be some benefits to foliar applications of those nutrients late in the growing season. So who knows, we may get there at some point, but right now we're really just trying to focus on the nitrogen problem and addressing that well.
In episode 11 of this podcast, we interviewed Matt Foley, Program Director of the Combine, which supports early-stage agtech companies in row crop, animal health, digital agriculture, and sustainability. Tell me about your connection to the Combine and how they've helped you and your company.
Yeah, the Combine has been amazing. I think they're an amazing resource for Lincoln and agtech specifically. Matt Foley has been a tremendous coach for us. So Sentinel Fertigation was fortunate enough to get accepted into the Combine as an incubator company back in September when we actually formed. And through that process, the Combine has given us a lot of resources for company formation, helping us to establish a website and just establish some of the basic operating procedures that a company really needs to succeed. They kind of have shown founders, a lot of founders, including myself, the ropes when it comes to fundraising and determining, kind of the optimal time to pursue fundraising. And so that's been tremendously helpful. And it's also really nice to have the network of other ag tech founders that are available through the Combine. I know I've gotten to know Jack Keating fairly well with Corral Technologies, which is he's doing some really cool stuff with virtual fencing. I've gotten to know the Grain Weevil team fairly well. Nave Analytics is another company that's in the Combine that we've shared some good conversations with. So it's really a tremendous community of ag tech companies that are supporting each other and really trying to drive the Nebraska ag tech ecosystem forward. We've since graduated from the Combine incubator. When you raise a funding round, you're actually able to graduate on, but Matt is still meeting with us, still coaching us. And so it's really great that the resources don't just go away when you become a graduate of the program.
So on the subject of fundraising, you just closed a $1.2 million pre-seed fundraise in May. That includes a $100,000 prototype grant from the Nebraska Department of Economic Development, a $25,000 strategic investment and development partnership with AgriInject of Yuma, Colorado, and a $25,000 Husker Venture Fund investment. How do you plan to use this investment to propel Sentinel forward, and what will the next phases look like for the company?
Really, really good question, and I feel very fortunate that we had so many investors decide to get behind this technology and behind our company. Really, the big focus of this fundraise was to put a team together behind Sentinel Fertigation that would enable us to achieve some of our long-term objectives, as well as short-term objectives, and also to generate enough traction to really demonstrate that our solution is viable and desirable within the marketplace. So those were really the two main objectives. I was really happy with the group of investors that we got on board. You mentioned the AgriInject investment. AgriInject is an original equipment manufacturer for fertigation and chemigation pumps, and they have one of the leading Internet of Things solutions for fertigation pumps on the market. And what these pumps allow folks to do is to remotely control their fertilizer applications through the center pivot or through any other sort of irrigation system, which is a huge quality of life benefit to farmers, as well as honestly a huge safety benefit. And an accuracy benefit, ensuring that crops receive the actual amount that they need where and when they're supposed to. And we're really looking forward to integrating our technology with recommendations and prescriptive capabilities with these pumps that are capable of executing variable rate fertigation prescriptions with remote control. So it's really going to enable next generation fertigation management out there in the marketplace. Husker Venture Fund, as you mentioned, it was really cool to be the first portfolio company for the Husker Venture Fund, and it was a great opportunity for both of us as Nebraska entities. We're a kind of a UNL company. I mean, we came right out of UNL, and then the Husker Venture Fund was able to support a student-led company with their first investment. So it seems like that entire organization is doing exactly what it was built to do. And the state of Nebraska has been awesome in providing funding to help us get off the ground with our minimum viable product, which is the end-time fertigation management system, which is now a web-based software that, as you mentioned earlier, has been launched in the marketplace and is currently serving customers. And that funding from the NDED, the $100,000 that we received in prototype grant funding, really allowed us to get that product development launched and get the product into a place where it could be available to customers here in 2022. We've also had Burlington Capital Ag Venture jump in, Invest Nebraska, Proven Ventures, and the Nebraska Angels all contributed in this funding round, and they've all been absolutely instrumental in helping us to build a team that now consists of 2 software engineers, an implementation specialist. I've been able to go full-time on the business, and we also have 2 interns, one from the University of Nebraska-Lincoln and one from the University of Nebraska-Omaha on our team, which is they've been hugely helpful so far as well.
Congratulations on getting that funding and
thank you.
Expanding out your team. That's exciting. And also launching In Time within the last couple weeks. So
it's been an exciting process. Certainly has not been bump-free getting it out into the marketplace, but so far I think a lot of our customers are finding value in the product, and it's really exciting to be able to pull up imagery on pretty much any of our fields that are already in season mode and help monitor and make fertigation decisions. We were actually just helping somebody with their first fertigation decision before I came up here to record, so that was kind of a cool experience to have that first recommendation go out.
So we know that technology adoption among growers is generally low for several reasons. They have a lot of apps that are available to them, and they need to see the value in that. What do you see are 3 of the most important characteristics of a particular technology when you're trying to get a high adoption rate by growers and the ag industry as a whole?
Now you're asking tough questions. Naming the top 3 is a really, really hard thing to do. I think the number one thing that needs to be done is simplification. And I don't mean simplification from a functionality or feature standpoint, but I mean simplification in terms of how information is presented to the end user. So the app itself, in order to be able to properly recommend or make decisions within a complex agricultural system, needs to have complex functionality. But at the end of the day, the end user doesn't really need to be presented with all the complexity, but only what is the actionable decision that needs to be made. And so that's something that we really seek to provide is recommendations that are essentially binary, right? So even taking it from 3 options down to 2, you either need to fertigate or you don't need to fertigate. And this is our standard recommended rate if you do. Will it eventually get a little bit more complex than that? Sure. but the delivery is going to be essentially the same paradigm the entire way through, where we're trying to distill it into just the immediately actionable information and recommendation necessary. And I think that's really important across all sorts of applications in precision ag. I guess the second thing that I would say is necessary is adaptation and integration with how farmers are currently managing their operations. So understanding what the pain points are around the technology, because oftentimes I don't think it's the technology that the end user finds an issue with, but it's often how it integrates with the rest of their operations. So I think that's something that critically precision ag technologies need to look at, is how does this technology, these recommendations, these prescribed actions, how do they fit in with the equipment that a farmer is currently using on their farm? How do they fit in with the logistics, the operational capacity of that farm? If we're to make fertigation recommendations that ultimately take more time for farmers, they're likely not going to use it long term. And so are we going to be able to build in some sort of logistics functionality that helps them to determine how much fertilizer they need to get to the field, determine which field is most important to address first, determine how they're able to transfer this prescription to an operator other than themselves that may be the one who's actually going out and making the application. And so ultimately, those are the things that have to be understood even more so than the technology, because otherwise that technology I don't think is going to be used very well, simply because of the overhead. And I guess the last thing I would say is that trusted advisors really need to be involved in the precision ag technology process. So if there is a trusted advisor on a farm, which most farmers have one trusted advisor or another, they need to have essentially the same level of access as that farmer to the system, to the data, so that they're able to help interpret decisions. And in some cases, their entire job is to pay attention to these particular issues or decisions that need to be made instead of the farmer. And so they need to be kept in the loop so that they can translate what is actionable to the farmer. And additionally, they're often the gatekeepers on data. They often have a lot of the data that is necessary to configure ag tech programs. And so they're an absolutely essential piece of the value delivery chain. And they're somebody we're seeking to keep in the loop, but it truly is challenging to figure out exactly how to appropriately manage those relationships. So yeah, I would say simplicity, understanding the entire system around the ag tech that's being implemented, and then keeping the trusted advisors in the loop are probably the three main things that I would say ag tech needs in order to be adopted successfully.
In your experience as a student and now CEO of an ag startup, what are some of the biggest takeaways you can share with us today?
There's a tremendous difference, and I'm learning it every day, between technologies that are kind of in the research phase, even if it's on-farm research, and technologies that get applied at scale. One of our biggest challenges, at least for me personally so far, has been figuring out our imagery supply chain. Truthfully, I think there are still some major gaps out there in terms of imagery availability. And I shouldn't just say imagery availability. You can get imagery just about anywhere, but getting quality imagery delivered, filtered, vetted the right way is a tremendous challenge. We never faced that in research because we always had control over our own images. And it's just something that you anticipate but don't necessarily know how to solve at scale. I've just become acutely aware of some of the challenges of scaling beyond successful research. I also think, I am looking forward to seeing more industry and academic collaboration in the right ways. I think nationally in general, but specifically here in Nebraska, there are some initiatives around the Farm of the Future project and other things that I think are going to allow for better industry collaboration with the university, maybe particularly around startups. And so I just am very excited about that because I think it was one area that was a little bit lacking when I was in graduate school, and I think would be a tremendous asset for growth of ag tech here in Nebraska.
What impact do you hope the next generation of ag tech entrepreneurs engaging in startups like yourself will have on the industry? Specifically, what impact do you hope Sentinel will have, and what does success look like for the company?
The main thing that I hope ag tech is able to achieve really in the next, 5 to 10 years is finally attaining win-win solutions for sustainability and farmers. I think there's often been generally a feeling that you can't have positive outcomes for both the environment and farmers. And I think agtech is pretty much going to be responsible for changing that. And I think it's essential to changing that. Ultimately, I think a combination of agtech, regenerative farming, and really some of the biological solutions that we have coming into the marketplace right now, specifically around fertilizers, but also for pesticides and other inputs. I think all of these practices are going to come together and really produce a system that is a win-win solution for everybody. And that's what I hope Sentinel can contribute to in some small way within the marketplace. I mean, we're specifically addressing fertigation, which is a niche market, but it's critical within irrigated corn production. And I think if we can manage to optimize nitrogen fertilizer applications to exactly what the crop needs when it needs it, and tremendously reduce nitrate leaching into groundwater, potentially reduce some of the greenhouse gas emissions associated with nitrogen applications, reduce greenhouse gas emissions that are associated with fertilizer production, potentially if there's less demand, and also keep more money in farmers' pockets. I mean, I think we're going to be part of generating those win-win solutions.
What do you see as DWFI's role in your journey, and how can we continue to help you, your company, and others like you?
DWFI was, I would say, essential for getting me thinking about the entire ag system in Nebraska. The supported student program was really great from the standpoint that it brought together students from across campus in different disciplines who had some sort of involvement in agriculture or essentially industries that impact our water resources. And so getting to understand other students' projects, some of the other research that was going on around the university really helped me to understand how everything works together to essentially generate positive outcomes within agriculture and within water resources. So I was really thankful for that systems level thinking approach that I think spanned the entirety of my graduate career and allowed me to think about how all of the different stakeholders within our agricultural ecosystem, from startup companies to major agricultural companies to NRDs to foundations to the university, all contribute to generating positive outcomes and getting solutions really in the hands of producers. And so I've been very appreciative of how DWFI has facilitated that growth. Obviously, the funding was critical to supporting this project and ensuring that it could be done the right way. And I think in terms of how DWFI can continue to support students like myself, companies like ours, I've seen some of the agtech ecosystem maps that have come out of DWFI, and I think some of the awareness that's being brought to agtech in Nebraska through DWFI is a really great resource to have. I think the promotion that is going on through this podcast, for example, of the positive things that are happening in Nebraska, and really I think DWFI is starting to do a really good job of facilitating collaborations between these stakeholders, even more so than just providing awareness or allowing students to think about kind of the interactions between these stakeholders, but really bringing these stakeholders together in the same place. For example, the field day that we're going to have in August, I'm really excited about going to that. And I think there are a lot of other events like that field day where agtech entrepreneurs, researchers, producers, NRDs are able to get together and really talk about issues in a very transparent way. And I think DWFI sitting at the nexus and facilitating those interactions is a critical way to support the growth of our agtech ecosystem.
Jackson, I'd just like to thank you for stopping by and providing this great insight for us and our listeners. And we look forward to seeing what's next for you in Sentinel Fertigation and how you're going to improve the agricultural industry. So thank you very much.
Well, thank you very much for having me. It was my pleasure to be here.
Thanks for joining us this time on the Doherty Water for Food podcast. Make sure to visit our website, waterforfood.nebraska.edu, to view show notes or subscribe so you don't miss future episodes.